Problem 6 talks about all the arithmetic of functions that we're going to add, subtract, multiply, divide, and mostly it's just knowing what the notation means, especially when we get into compositions. Okay, so I've given 1, 2, 3, 4 functions here and want to find each of them and simplify. So g of 1 just means I take the g function g of x equals 3 over x minus 4, and then g of 1 means I replace the x with 1. So that's 3 over 1 minus 4. That gives me 3 over negative 3, which is negative 1. If I have k of negative 3, well, k of x is equal to x to the third minus 3x plus 1. So k of negative 3 means I replace the x with negative 3 to the third minus 3 times negative 3 plus 1. Negative 3 times negative 3 is 9, times negative 3 is negative 27. Negative 3 times negative 3 is plus 9, plus 1. And that gives me negative 17. Okay. All right, f plus k of x really means f of x plus k of x. So that gives us 3x minus 4 plus x to the third minus 3x plus 1. Since it's adding, I can just drop the parentheses and combine like terms. So let's see. That gives me 3x minus 4 plus x to the third plus 3x minus 1. So I have a single x to the third. Oops, this is minus, sorry. 3x plus negative 3x is gone. Negative 4 minus 1 that's a plus, sorry. Negative 4 plus 1 is negative 3. So there's my answer. Okay. If I have f times g of 3, this is the same thing of saying f of 3 times g of 3. Now there are two ways you can look at this one. You can find f of 3 and you can find g of 3, and then you can multiply them. So I'm going to do that. So f of 3 is equal to 3 times 3 minus 4 which is 9 minus 4, which is 5. G of 3 is equal to 3 divided by 3 minus 4. We already did this. This is 3 over negative 1, which is negative 3. So f of 3 times g of 3 is equal to 5 times negative 3, which is negative 15. Okay, so I printed these again on here. So if I want to do f dot k of x, this is the same thing as saying f of k of x. That means the output of this function becomes the input of this one. This is called the inside function and the outside function. So that means wherever I see an x in f of x, I'm going to replace it with x to the third minus 3x plus 1. So that is the same thing as saying f of x to the third minus 3x plus 1, which means 3 times x to the third minus 3x plus 1 minus 4. I almost forgot the minus 4. So that's 3x to the third minus 9x plus 3 minus 4, which gives me 3x to the third minus 9x minus 1. Okay, g of 4 just means evaluate the g function when x is 4. So g of x is equal to 3 divided by x minus 4. So g of 4 is going to be 3 over 4 minus 4. That gives me 3 over 0, which is undefined. You cannot divide by 0. All right, if I have k dot g of negative 2, this is the same thing as saying k of g of negative 2. Well, that means I want to find g of negative 2. So g of negative 2 is equal to 3 divided by negative 2 minus 4, which is 3 divided by negative 6, which is negative 1/2. So now I want to find k of negative 1/2. Well, my function, you can't see it up here, but we know what this is. K of x is x to the third minus 3 times x plus 1. Okay, that gives me negative 1/2 times negative 1/2 times negative 1/2, which is negative 1/8. 3 over 1 times negative 1 over 2 is a positive 3/2 plus 1. So now to combine these, I have to get a common denominator. Well, it's going to be 8. To turn this into something over 8, I have to multiply by 4 over 4. And I'm going to have to multiply this by 8 over 8. So that gives me negative 1/8 plus 12/8 plus 8/8. Negative 1 plus 12 is 11 plus 8. That gives me 19 over 8. All right, if I do k minus f of 5, this is the same thing as saying k of 5 minus f of 5. And this one, you can either put the functions together and then substitute in a 5, or you can find k of 5 and find f of 5 and then subtract them. It doesn't make any difference. But k of 5 is going to be five to the third minus 3 times 5 plus 1, which gives me 125 minus 15 plus 1, which is 125, 110, which is 111. Then f of 5 is, so I'm going to subtract, is 3 times 5 minus 4. So that's 15 minus 4, which is 11. And 111 minus 11 is 100. Okay, k over h of 8. This means k of 8 divided by h of 8. And once again, you can find k of 8 and then find h of 8 and divide them. Okay, so k of 8 is 8 to the third minus 3 times 8 plus 1. And I cheated and did this before. This is 489. H of 8 is the square root of 8 plus 1, which is the square root of 9, which is 3. So k over h of 8 is equal to k of 8 over h of 8, which is 489 divided by 3, which is 163. All right, k dot f of negative 1 is the same thing as saying k of f of negative 1. That means the output of f when f is negative 1 is the input of k. So let's start out by finding f of negative 1. That's 3 times negative 1 minus 4, which is negative 7. Then I'm going to put that inside of k, so I'm going to have k of negative 7, which gives me negative 7 to the third minus 3 times negative 7 plus 1, which is negative 321. And I keep forgetting to box my answers. Okay, if you have h times g of 15, notice the difference in the notation. This is a little bitty dot. This is a circle. This is the same thing as saying h of 15 times g of 15. Well, h of 15 is equal to the square root of 15 plus 1, which is the square root of 16, which is 4. G of 15 is equal to 3 over 15 minus 4, which is 3 over 11. So h of 15 times g of 15 is equal to 4 times 3 over 11. And of course we know if we have a fraction, then we just put it over 1, multiplying numerator times numerator, denominator times denominator. So this is 12 over 11. Okay, k of negative 2a means I replace the x with negative 2a. So this, we know k of x is x to the third minus 3x plus 1. So k of 2a, negative 2a is negative 2a to the third minus 3 times negative 2a plus 1. Negative 2 times negative 2 times negative 2 is negative 8. A times a times a is a to the third. Negative times negative gives me a positive 6a plus 1. I can't simplify it anymore. So there's my answer. Okay, and that's it.